I want to very quickly look at two probability issues. The first one relates to DNA, the probabilities of DNA hybridization. If you have three bases, the probabilities of a match against three bases are 4 to the third, 3 being the three bases. A typical PCR primer is 20 bases. The probabilities of a random match with 20 bases is 4 to the 20th, which is approximately 1 trillion. So a 20 base primer has plenty of specificity against the 3 billion base human genome. The second probability question is kind of a general chemistry issue. Arguably, chemistry is all about, everything is related to probabilities. What are the probabilities of two molecules coming into contact with each other? Well, it's temperature related and very much concentration related. And then when the molecules do come in contact, what is the probability of something happening? So I'm probably not the sharpest knife in the drawer. I ask the question, why do the primers 20 bases long find the right spot among the 3 billion bases in the human genome? And so it's like, this doesn't seem to make any sense to me. The key to it is that the primers are in vast excess over the original DNA. You have the DNA template, but the primers are in vast excess. The vial that goes into the thermocycler is a soup of primers and trinucleotides, and then there's a little bit of template DNA in it. The primer is not a catalyst. The primer becomes part of the amplicon. The DNA product includes 2 primers. So if you have 2 million amplicons, you used up 2 million primers, and actually there's 2 on each one, so you use 4 million primers. There's a lot of primers in there. And then the last point is that the researchers that do research in this field typically put a label on the primer. The primer becomes part of the amplicon. So if you put a label on the primer, you can trace where the amplicon is going.